phone charger is lying to you, and it's beautiful. Most people think electricity just flows straight from the plug to your device, like water through a pipe, but that's not quite right. Direct current, DC, does flow steadily in one direction. Think of a battery, positive to negative, always the same way. Simple, predictable, reliable for small gadgets. But the power coming out of your wall socket here in Dubai, that's alternating current, AC. It doesn't just flow, it reverses direction completely, flipping back and forth 100 times every single second. That perfect repeating wave shape you're watching right now, that's the famous sine wave. Let's take our time and really break down this beautiful curve. The distance from the center line to the highest point is called the amplitude. It represents the maximum voltage swing, how strong the push and pull really gets. The time for one complete up and down and back cycle, from one peak to the next, is the period. In the United Arab Emirates, our grid runs at 50 Hertz. That means 50 full cycles every second. So each period lasts just 0.02 seconds. Incredibly fast, yet perfectly consistent. The mathematical description is surprisingly simple and elegant. V of t equals V peak times sine of 2 pi times 50 times t. And here's the detail most textbooks gloss over. Your wall socket is rated at 230 volts, but that's the RMS value, root mean square, the effective value that tells you how much real power it delivers, equivalent to 230 volts of steady DC. The actual instantaneous voltage swings up to about 325 volts positive, then down to minus 325 volts, and back again, 100 times per second. That massive oscillation is what the sine wave captures, and it's happening silently behind every outlet in your home. So, where does this remarkably perfect sine wave actually come from? It all goes back to basic electromagnetism. Inside every major power station, whether coal, gas, nuclear, or even solar thermal here in the region, there's a massive coil of wire called the armature, rotating steadily inside a powerful magnetic field. As that coil spins at a constant angular speed, the magnetic flux through it changes sinusoidally. By Faraday's law of induction, the generated voltage follows the exact same smooth mathematical curve, a pure sine wave. No square waves, no triangles, no messy distortions, just pure, elegant physics emerging naturally from rotation and magnetism. That's why AC became the global standard over a century ago. You can easily step the voltage up for long-distance transmission with almost no loss, using simple transformers, then step it back down safely for homes. In the UAE's 400 kilovolt supergrid, that efficiency lets power travel hundreds of kilometers from plants in Abu Dhabi or Dubai right to your socket, all riding on those perfect sine waves. In the end, that humble sine wave isn't just a graph. It's the hidden heartbeat of modern civilization, the reason lights turn on, phones charge, and entire cities stay powered 24/7. Thanks for watching. If this sparked your curiosity about electricity, there's so much more to explore.